Thank you so much for inviting me to speak here. I would love to talk a bit about the topic of messaging, encrypted messengers, and why it's actually such a difficult problem to solve. So, in this talk, we'll talk a bit about the basics of how encryption and encrypted messengers actually work. And we'll also look at some of the key differences between platforms such as WhatsApp, Telegram, Signal, and the like. So, first of all, encryption is an interesting problem. So on the one hand, it's been around for a very, very long time, right? So like militaries in the Second World War, for example, would encrypt things using secret codes, send them onto spies, send them onto boats. Encryption has been around for almost as long as communication has been around for. But actually getting encryption to be really, really user-friendly is super difficult. So in the 70s, 80s maybe, when we started to really get into cryptography on computers, and when we first started to include encrypted emails using a technology called PGP or pretty good privacy, encryption was still pretty cumbersome and difficult to do, right? So you had to have your public key, which is what you shared with other people. You had to have a private key, which you had yourself. You had to make sure that you never, ever, ever accidentally shared your private key instead of your public key, which has happened, unfortunately, in many, many cases. So you gave other people the ability to decrypt all your messages. It was weird, it was difficult, it was cumbersome. And this is one of the big reasons why very, very few people use encrypted emails anymore. Instead, most of us have actually switched to encrypted messengers. Those encrypted messages can include WhatsApp, they can include Signal, and in many ways they can include Telegram as well. So sort of encrypted messengers have done a couple of things. One of the big ones is that the exchange of cryptography keys actually becomes quite automatic, right? So if you had encrypted email, you had to sort of move, for example, your mouse pointer around the screen, and the random movements would lead to the generation of random data, and then this random data would, for example, be your encryption key. They need to send your encryption key to somebody else, and it's a pretty weird process. It requires a lot of steps, and you can make a lot of mistakes. Now with encrypted messengers, what's happened is that the moment you connect to somebody, the moment you text somebody on WhatsApp, bam, like you are already connected and you're already encrypted. And this has happened for a couple of things. One of those is that the moment you start a conversation, you no longer have to manually send your keys through, but instead the keys are automatically generated. And this takes some really, really clever math. I'm not going to get into math in a lot of depth, but essentially what it means is that both of the devices have to send each other encryption keys in such a way that both of them understand and can verify the encryption keys without necessarily being able to read them. If you are interested in looking a bit into the Wikipedia rabbit hole that's responsible for that, look up the socialist millionaire problem. It's a really, really weird and cool sort of math discussion that really sheds light on a lot of the underlying basis of encryption. So we've sort of had secure messengers, and secure messengers are great because unlike with secure emails, secure messengers do everything by default. But still, when it comes to things like zero knowledge encryption or a zero knowledge messenger, things become even more difficult. Because we've had something like WhatsApp, and WhatsApp has for a while already been able to relay messages that are fully encrypted. But there still has to be somebody in charge of passing this message from one person to another, right? So for example, if one person, let's say in Kiev, wants to send another message to somebody in London, there usually has to be some sort of server or intermediary that passes them. And in general, it's much, much easier to pass messages if you actually know which people you're passing them from. So for example, if I gave you an envelope and told you go and take this envelope to somebody else, take this envelope to, let's say, Jane, who lives in London, you have to know, even if you don't know the content of the envelope, you have to know that the message is going to Jane from London. So for many people, this is still quite problematic. Because it means that, for example, even if their WhatsApp or Facebook servers, because Facebook owns WhatsApp now, do not know the content of the message, they still know whom you are communicating with. For many people, this is quite a big deal breaker. So what's been happening in the past sort of couple of years and months in cryptography and in secure messengers has been something that the Signal messenger introduced. And that's a really, really interesting technology by which Signal can actually send messages between people without knowing who those people are. This requires some very, very clever software and hardware tricks. If you want to read a bit more in depth about it, they've been documented pretty well on the Signal servers. And the software and hardware tricks essentially mean that the Signal servers can relay messages from one person to another without actually knowing who those people are. So essentially now not only can I give an encrypted letter to the server and say send it to Jane who's in London, I can even tell the service send it to, for example, person with such and such an ID number, but the server does not actually know which person stands behind this ID number. So that's been a really, really clever thing, right? But there have, of course, been some troubles with this approach. And I think that every time we look at the history of secure messengers, we realize that messaging is all about lots and lots of trade-offs, right? So, for example, even encryption is a trade-off. It's a trade-off, for example, between security and archivization. Because suddenly, if you lose the encryption keys, you no longer have any access. And that's like the first big trade-off of security. The second big trade-off that we could talk about is sort of the trade-off in terms of metadata and contacts. Because if, for example, the server does not know whom you are sending the message to and it's doing it in a very invisible way, it means that the server cannot store, for example, any contacts in itself. So because of the way Signal has been engineered, it is mostly needed to rely on phone numbers in order to relay messages to people. There have been some other messengers, such as Wire, which have been using usernames. But the problem is that if you have usernames, you have to have those usernames saved in a server somewhere. So the server knows who's signed up and knows who's communicating. In Signal, on the other hand, if you have phone numbers, those phone numbers are saved in everybody's phone. So the address books are actually in people's phones. But once again, those are very, very difficult trade-offs, right? Some people really don't want to share the phone numbers. Some countries even have compulsory registration of phone numbers. So this essentially means that if your phone number is registered in a certain country, you have to, for example, come with your passport or identification document. So even if you try to be anonymous on Telegram, Signal, or WhatsApp, your phone number could still be traced back because the government would have a list of who's behind each phone number. So for a lot of those people, those things are unacceptable. For some other people, this sort of idea that the server knows whom you are messaging is unacceptable. So whenever we go into security, we go into really, really deep and interesting and weird trade-offs. And we sort of see this with every platform, and we see this with every solution, really. And for the second part, let's very briefly look at the differences between a couple of the main messengers that we have. So WhatsApp, Signal, and Telegram. I know that there's many, many other messengers. I know that there's Viber, that there's Wire, but unfortunately doing a huge security analysis of all of them would be a tiny bit too time consuming, but we can do this at another time. Like, hopefully we'll have another webinar series where we can look at all the messengers. Maybe not all of them, but all the major messengers. So yeah, so WhatsApp is the most popular one. Now WhatsApp actually uses the same scheme as Signal to encrypt messages. So essentially both of them use sort of the same algorithm, the same formula in order to encrypt the messages. One of the main differences is that first of all, WhatsApp is owned by Facebook, whereby Signal is owned by private NGO and foundation. So a lot of people trust Signal more than WhatsApp because they don't trust Facebook. And the other thing is, as I said, sort of, WhatsApp servers know whom you are forwarding your information to. WhatsApp servers know whom you are messaging, where Signal servers do not know that. So for some people, for example, it's an unacceptable trade-off that Facebook knows whom you're messaging and when. For some people, it's an unacceptable trade-off, for example, that your address book is being uploaded to Facebook. So some people really prefer Signal for this reason. On the other hand, sort of, if you're looking at a purely security situation, maybe there are some situations in which WhatsApp will be more secure. Like, sure, your information might be uploaded and done via Facebook servers, but there might, for example, be places in the world where if you are a Signal user, it's suspicious, because Signal is very often used by journalists, security professionals, and many others. So maybe there will be places in the world where sort of using Signal rather than WhatsApp will make you a little bit more suspicious. There might be places in the world where Signal is so common, and I hope that we all start using Signal widely so that it becomes so common, but it's no longer seen as suspicious. But once again, that's the thing. Nobody can tell you your security model. What you need to do is you need to understand what is your security situation? How do you feel? How do you know the terrain? Like, we can tell you about the tools, but your security model is something that you can get a lot of help on, and we can always discuss it. But ultimately, your security model is something that is up to you and up to you alone to decide. So now the thing is that Telegram is slightly different from WhatsApp and Signal because Telegram has actually created its own encryption protocol. Now, in general, that's a bad idea. That's most cryptographers will tell you that the number one rule of crypto is never create your own crypto. Always rely on the professionals to create your own crypto. So I think that Telegram has created quite a few red flags in terms of cryptography. The owner of Telegram, Pavel Durov, has also not always been very, very good at communicating. And if you look, for example, at the forums and the like, not only did Telegram sometimes make quite misleading claims, for example, describing itself as more secure than WhatsApp without giving that many details, but the owner of Telegram has also not been very detailed about the privacy and communication. Finally, sort of Telegram has a really interesting model, because remember when we were talking about trade-offs? So Telegram works on many different devices at once, if you don't have the secure chat option, if you have the non-secure chat option. So essentially, under this thing, Telegram servers keep the keys. So theoretically, although Telegram claims it's not technically possible, but theoretically, Telegram servers could read your messages. But this also means that they can deliver your messages to so many devices. They can deliver it to your phone, to your laptop, to let's say another computer. And all of those devices, or all but one of those devices, could be turned off. If you look at WhatsApp Web, for example, WhatsApp Web requires your phone to be turned on, precisely because your phone is the only device that it works on. So once again, so WhatsApp might have harder and tougher crypto. WhatsApp might be in most cases very much more secure, but WhatsApp, for example, has much bigger problems with having multi-device. And Telegram is theoretically working for many devices. So Signal is theoretically working well for many devices, but it doesn't always deliver so well. So in some cases, sort of, depending on what you want to use, the slightly less secure solution, like Telegram, might be best. Telegram also has amazing stickers. Maybe, your focus is on communicating via stickers rather than security because you're a graphic designer. In many of those cases, there is no perfect messaging product. And I very, very strongly encourage as many of you as possible to switch to sort of stuff like Signal, maybe WhatsApp as well, because they are seen as the most secure ones, both from, let's say, attacks by groups like states and for groups by non-state actors. But in many cases, sort of your decision can be based on many factors. Telegram allows you to communicate, for example, as does Wire, with a username rather than phone number. For some of you, using a phone number might be a deal breaker. For some of you, sort of having your information stored on servers might be a deal breaker. So unfortunately, I know usually when we sit down at those sessions, one of the most common questions is, what messenger should I use? And unfortunately, by now the answer has become, it depends. I will probably clarify this a bit more and say that for 99.99% of people, the ideal solution is Signal or WhatsApp. For the rest of us, who have slightly more specific security requirements, I'm very sorry to say, the answer is still, it depends. Thank you so much, and I hope that you have a wonderful day, and best of luck, and communicate privately and securely. See you!